I'm Anil Kumar and we are discussing limits and continuity. The question here is, if f of x is equal to square root of x minus 3 when x is greater than 3 and 6 minus 2x when x is less than 3, determine whether limit of f of x exists when x approaches 3 or not. And part 2 is the given function continuous? Now for the function to be continuous, limit should exist and the limit should be equal to the value of function, right? That is important. So let's first figure out what is the limit of this function. So we'll find the limit of the function as x approaches 3 from negative side, right? And also limit of the function as x approaches 3 from the right side. And if both these limits are same, in that case the limit exists. If both these limits are different or one of them doesn't exist, then we know that the limit does not exist. So when we say limit of this function when x is approaching from the left side, that means x is less than 3. So we'll follow this 6 minus 2x. So in 6 minus 2x we can write this as limit x approaches 3 minus, and the function here is 6 minus 2x, right? So here the limit is equal to, we could write this as, when I substitute 3 here, 6 minus 2 times 3, we get 6 minus 2 times 3, and that is 0. So this limit, left side limit for us is equal to 0. Now let's calculate the right side limit. So when we are calculating the right side limit, when 3 is from the right side, that means x is greater than 3. So we'll use that part of the piecewise function. So we could write like this, limit when x approaches 3 plus, and the function will be square root of x minus 3. Now in this case, if I substitute 3, then I get 0. So here also we get limit, no need to write limit now. Substitute 3 here, so we get 3 minus 3, which is 0. So in this case, this limit is 0. Now since the left side and right side limits are both 0, we say that the limit of this function exists and it is equals to 0, right? So the limit is equal to 0 since it is from both sides the same value. Now let us discuss continuity of the function. For continuity, one of the condition is that the limit should exist, which exists in this case. The second condition is value of function, right? So value of function, right? This is what we are interested in finding. So what is the value of the function at 3? As you can see from here, it is square root of x minus 3 when x is greater than 3 and 6 minus 2x when x is less than 3. Function is not defined. So at 3 it is not defined. Do you see that? Limit exists, but the function is not defined at 3, and therefore we will say it is not continuous. Do you see? It is not defined. So the function is discontinuous at x equals to 3, right? So what you can also do is you can sketch and show the result. So for example, in this particular case, what you really have a square root function which starts from 3, right? So when x is greater than 3, then we have x minus square root 3. So that's kind of square root function which you have. So this is not including, so there is a hole here at 3. On the other hand, we have a linear function, 6 minus 2x, correct? So if I write x equals to 0, I get 6 as my value, correct? So I could draw this piece of the graph as something like this. So we could join this point where, this value is 6. So let me just join it first and then, it is continuous. Okay, this is filled in, Okay, but the value at 3 is not defined. So we have a hole here at 3. Do you see that? And that is the discontinuity. So the type of discontinuity is a hole at x equals to 3, right? And that is how the function looks like. This point will be 6 for us, correct? So that is how it is going to be. So if you have to sketch the function and explain, you could do it like this. So straight away when you read the function, you know it is not defined at 3. So it is discontinuous at 3. Now at times the question could be, how can you modify f of x to make it continuous, right? So we could do a modification here, and the modification could be kind of like this. We already know it is x minus 3 square root when x is greater than 3, and we also know it is 6 minus 2x when x is less than 3. You could say let the function be equal to 0 for x equals to 3. In that case, let me call this as p of x, a modified function. So this modified function, you could plug in this hole, right? By utilizing this, adding one more property to the function, that is, let it be 0 for x equals to 3, you can make this function continuous. So that could be an extension to this particular question. How can you change your function or modify f of x to make it continuous at 3? So that is how you can do it. I hope that helps. Thank you and all the best.